Hey guys, let's finish up Chapter 5, Section 1. I didn't realize how making videos is, you know, a little different than being in front of the whole class, for the simple fact that, excuse me, if I make a mistake in front of the whole class, I can just reach up, do a little erase, say, yep, thanks for pointing that out. But here, I have to redo the video, and it's driving me insane. My OCD is killing me. That being said, let's finish this up, okay? So the last part of 5.1, we've been dealing with using these fundamental identities, and we'll do a few more examples just to show you kind of what these, what some of the advanced, problems look like. This is a simple factoring problem. We're asked to simplify this expression. If you notice this subtraction symbol, okay, it turns this into a binomial. We have a left side and a right side, and there is a common factor. So guys, you can factor this common factor out just like you would any other variable, okay? Since sin x is common to both this left side and the right side, we can take it out. Dividing both of these by sin x turns this into cosine squared x minus 1. Okay? So we have to ask ourselves, are we done? Okay? Can we simplify this more? And the answer is we can definitely simplify this more. There are a couple different ways. One way would be to use a Pythagorean identity and say, hey, you know what? I remember seeing 1 minus cosine squared, and that's equal to sine squared. We can take this cosine squared x minus 1 out, and we can plug and play. We can put in a sine squared x. Oh, no we can't, can we? Because if you look, this is sine squared x, and this is 1 minus cosine squared x. I guess there'll be no substitution here today. Or, what happens? What happens if I go ahead and instead of moving the cosine to the other side, which gave us the second one, what if I go ahead and I move the 1 to the same side as the cosine? That would give us cosine squared minus 1. And let's move the sine squared x to the other side. Well, ladies and gentlemen, that would give us cosine squared x minus 1 is equal to negative sine squared x. So we can take this out and we can put in its place a negative sine squared x. Sine x times sine squared x is sine cubed x. And that is our simplified answer. Don't worry, you'll get it. Okay? Alright, let's look at the next one. Okay? Secant squared minus 1. Okay, so when I see this, I look at this, I see a difference of squares. So let's just factor it into secant theta plus 1, secant theta minus 1. Secant theta plus 1, secant theta minus 1. Done. Okay? It's a difference of squares. Square minus a square. This next one though. Okay? When you look, if you look and you see 4 tangent squared plus tangent x minus 3, I see 4x squared plus x minus 3. I'm going to factor this the same way. Okay? Just because we're dealing with trig functions doesn't mean our algebra rules. So, when I factor this, I say, oh, 4 times negative 3 is negative 12. Factors of negative 12 that add up to be positive 1, 4 negative 3. So 4x squared plus 4x minus 3x minus 3. What do the first two have in common? 4 and x. So when we go ahead, then we say, oh, what do the second two have in common? A negative 3. Or use your FOIL to follow 4x times x is 4x squared. Negative 3 times 1 is negative 3. Transferring that to this side, that's the same thing. 4 tangent x minus 3 tangent x plus 1. When you multiply this out, that would give us 4 tangent squared plus 4 times tangent x is 4 tangent x minus 3 tangent x's will give us 1 tangent x, and then negative 3 times 1 is negative 3. Eventually, we're going to put this equal to 0 and we're going to solve. But for now, we're just asked to factor. Alright, let's move on to the next example. Okay, we're getting there. The next example is a little bit uglier. Okay, it's ugly because it's a mix of cosecant and cotangent. Looking at our sheet, I don't see any identity right now that relates cosecant to cotangent. I just don't see it. So the Pythagorean we have is sine squared x plus cosine squared x equals 1. Mathematicians are genius. It took someone dividing everything by sine squared x to develop a new Pythagorean identity. Sine squared divided by sine squared is 1. Plus cosine squared divided by sine squared, well, guys, that would be cotangent squared x. If you don't believe me, just look at your quotient identity. Equals 1 over sine squared, which is, guess what? Cosecant squared. 1 over sine is cosecant. So 1 over sine times 1 over sine would be cosecant times cosecant, cosecant squared. So that means we can substitute for cosecant squared x. So what are we going to put in? 1 plus cotangent squared x. Alright, a little bit of simplification going on. Cotangent squared x minus cotangent x, negative 3, positive 1, add them together and get negative 2. And let's factor it. Cotangent x makes cotangent squared. Factors of negative 2 that add up to be negative 1 would be a negative 2 and a positive 1. What do you think? I hope you like it. Alright, let's do one more example and then we'll call it a day. Yeah, it's 30. Alright. Here is the last example of 5.1. It's really brings in everything that we talked about before with the trig functions. And maybe extends it, maybe it doesn't. Anytime you see a trig function equals a fraction, what do? That's right, we draw a triangle. We're all students try calculus. Yeah, I think we can all come up with our own version of it. Alright, so we're looking for a quadrant. Okay, we're going to draw a triangle somewhere in one of these four, where the secant is negative. Now, if the secant's negative, then the cosine is negative. So we're in quadrants 2 or 3. But we're also looking for the one where the tangent's positive. The only quadrant that is true is in quadrant 3. Okay, so we have our angle U. Okay, now if the secant is negative 3 over 2, that means that the cosine is negative 2 over 3, which means that the adjacent side is negative 2, the hypotenuse is 3. Hypotenuse is always positive. Alright, so when we look at this, we need the Pythagorean theorem. 3 squared is 9, negative 2 squared, of course, is 4, and we need this y value. And so y squared is equal to 5, and y is equal to the square root of 5. Okay, since we're in quadrant 3, that's negative. Okay, so now we can finish the problem out. So the sine, of course, ratio of the op, which gives us negative radical 5 over 3. The reciprocal, of course, negative 3 over radical 5, which we need to rationalize, give us negative 3 radical 5 over 5. All right, down here with the tangent, and the opposite to the adjacent will be radical 5 over 2. The cotangent would then be 2 radical 5 over 5. Rationalized. Okay, so that is it for section 1. Please email me again with any questions, and have a great day, guys.